We're doing practice problems for our quiz on law of sine and cosine. Each time you see a problem, pause the video and try it yourself first, and then restart the video. Our first problem here, I see that we have angle B and side B, so I'm thinking that with the law of sines, I could find angle C. And I could draw the triangle first, or you could just get started right in here and then draw the triangle once you see what's happening. But I'm going to plug in our values here. And then each time that I'm calculating, to save time on the video, I'm going to actually pause the video to go to my calculator. So it might look like I'm calculating very quickly, but it'll really be happening while the video is paused. So I'm going to find this value as a decimal, and then I'm going to do inverse sine. So I'll be right back with the calculation. So I had 0.8518. I hit inverse sine to find out my approximate value for angle C. And since everything was given to tenths, I kept to the nearest tenth. And now remember that there are two possible angles that have that sign. So I also want to use the supplement of angle C and find out whether it works. So if you say, well, how do you know whether that's going to work? Once I find the supplement, then what I need is just one more angle in the triangle. So let's find out what angle A would be. What's left over? Well, I would take 180 minus 36.7 minus 48.4. So I'm just taking 180 minus angle B minus angle C. And I'm just going to scroll here to get some room. And that gives me angle A of 94.9 degrees. And then to find out if the other triangle works for A prime, of course I would do the same thing, but this time I would subtract C prime. So 180 minus 36.7 minus 131.6. And A prime turns out to equal 11.7 degrees. So since we still had room for angle A, that tells me that we're getting two triangles for this problem. So all that I have left to do now is to find the missing side. I already know side B, I already know side C. So now I have to find A and A prime. And we'll do that with law of sine. Now let's make sure everybody understands this. Let's take a look at this triangle. And you maybe drew this right off the bat. We want angle B to be fixed at 36.7 degrees. We want side B to be 8.7 meters. And we want side C to be 12.4 meters. So do you see our situation here that our instinct might be to have side AC cut to the outside, but couldn't we make an isosceles triangle and have C prime be here instead? So this is the situation with two triangles. What we just found out was that in our first case, angle C is 48.4. Because of the isosceles triangle, these angles are both 48.4. And then we found out that our C prime angle, that would be this purple angle right here, the supplement of 48.4 is 131.6. And they both worked. And we found out then that our angle A, this large angle in blue, this large angle was 94.9 degrees, but our angle A prime, and I'll again use purple here, is this small angle. So our angle A prime is only 11.7 degrees. So we've got two things left to go, and that would be side A of the long triangle. Let me change colors there since I used blue. Side A would go all the way across, and in purple, side B, side A prime would just be this short length. So I'm going to set those up using the law of sine, and then I'll come back to explain. What I know in both of these triangles is the given 8.7 for B and 36.7 for angle B were fixed. So I'm doing side B over sine of angle B is equal to our side A over angle A, and in this case I use this larger angle. And then for our second triangle, again, side B and angle B were fixed. So all I'm doing then is putting in angle A. And then in each case, I'm going to cross multiply. I'm going to move the sign to the numerator of the other side, and I'll have my answers. And I've calculated each of these two lengths, and what I like about my answers is that they seem reasonable. We know that side A is across from the largest triangle, the largest angle in the triangle. So it has the longest measure here, and our small letter A in this case is across from the smallest angle, so it should turn out to be the shortest side. So our calculations appear to work for two triangles. All right, you can always try that again if you're having trouble with those. All right, let's look at our next case. We're looking for the area of a triangle, and notice I've got side A, side B, and angle C. Angle C fits right in between those two. If we draw a diagram of this, this is our side angle side case. So we have an area formula that we know we can use here. And in this case, we're going to use 1/2 of AB sine of angle C. So couldn't be too much easier than this. We're going to plug the values into our formula and do the sine of 49 degrees, and then go to your calculator. And I came up with 4.9508, so I think I'm going to round this to 4.95, rounds up to 5.0. And we're in inches squared for an area. And our next problem, find the missing side. Here we're given 3 sides, so a side, side, side case. We better check to make sure that the 2 short sides add up to be long enough to reach, and here it's pretty clear that when you add those up, the 2 short sides do add up to be longer than the third side. So we want to start with law of cosine for this case, because we don't know a capital letter and a small letter that pair up for law of sine. So we're going to find the smaller angles first. The smaller 2 angles first. So where are they located? The smallest angle is across from the shortest side. So I'm going to find angle C first. So I'm going to use this version of the law of cosine. And again, if you were having trouble simplifying, maybe you want to solve this first. So since I did this differently in the other video, let me add this to the other side so that it will be positive. And let me subtract the c squared from this side, so it will be negative. And now I know cosine of c. And this might have helped. I didn't realize that simplifying the equation might be as difficult as actually memorizing the equation. So you might want to simplify first. And now we can plug in our values. We know A is 19.3, and you're going to do all of this work with your calculator. And when you're calculating, remember order of operations, you're going to have to put the numerator in parentheses, and then you're going to have to put the denominator in parentheses, so that you're not just multiplying by the first part of the denominator, but by the entire denominator. So nesting the parentheses might be an important part. Once I compute this as a fraction, then I'm going to do inverse cosine to find out what angle C is. So I'll be back after I calculate this. So we came up with an angle of about 44.7 for angle C. Now I could do law of cosine again to find the next smaller angle, but we are also at this point, because we have small letter c and capital letter C, we are able to switch to the law of sine, and the next smaller angle would be across from A. So I'm going to set up sine of C over small letter c, sine of A over small letter a. So we're going to use this law of sine. And I would multiply the 19.3 to the other side. And I hope the calculations aren't still causing trouble. Once I convert this fraction to a decimal, then I'm going to do the inverse sine button, and I'll be back with the answer. And I came up with angle A at approximately 55.4. So what's left for us to do is not trigonometry, but just geometry. We know that we can take 180 to find our angle B now. We're taking our entire 180 minus angle A minus angle C. So basically we're finding out how many degrees are left over. That'll be our answer for B. And I think it looks like 79.9 degrees. So you could double check to make sure that your three angles add up to 180. We never have to worry about two triangles with side, side, side. The only ambiguous case is ASS. All right, let's see what else we can get in our video yet. Find the area of a triangle if we have three sides. Well, again, those three sides, check out the two short sides. Looks familiar. Add up to be longer than the third side, so it's going to work. So we're going to use Hero's formula. We have to find the semi-perimeter. That would be half of the perimeter. And then we're going to use Hero's formula to find the area. And it's once we write in our numbers here, then we'll be set to just use our calculator. So I've taken our semi-perimeter, 29.45, and replaced that for each letter S. I've replaced the three sides for A, B, and C. And now we calculate. Don't forget to hit the square root symbol of all of that. Make sure on your calculator that you do the square root of the complete thing, so nest some parentheses around the square root. And I come up with an area of about 156.8, and our units are feet, so we want to make sure we label square feet. All right, let's quickly just set up this next question here so we don't miss that on the quiz. Look at these three sides, find the area of the triangle. Don't be too hasty and try doing Hero's formula here. Take a look at these two sides and notice our problem. 10.3 plus 6.5 is not long enough to reach. So if you try drawing this triangle, the 10.3 and the 6.5 are not going to reach, so there is no such triangle for this problem. That should help. Make sure you keep practicing till you're confident.